Okay, quick and close real quick for just a second. I see lots of questions on this kind of problem, and I get why. And then some people are doing this in a way that's too hard. Right? We can make this simpler. We don't have to put this completely into vertex form to graph it. Right? All we need to do, if we want to graph a quadratic function or recognize a graph of a quadratic function, all we really need is to know where the vertex is and one guide point outside of the vertex, so we can kind of get the shape of the parabola. That's it. Right? So how are we going to do that? They give us a quadratic function, kind of a tough one, fractional coefficients, in standard form. How can we come up with the coordinates of the vertex? What's the formula that we always use? If we're in standard form to start with, h equals, yeah, what is that, whatever? Negative b over 2a. So in this case, what is that? So that's going to give us, here we're going to get, there's A, and there's B, right? So we're going to get negative B is just positive 16/5. There's my negative B, right? Everybody agree? 1 over 2a. How can we deal with the 1 over 2a? Well, 1 over 2 is just 1/2. And then 1 over a is just the reciprocal of a. That's the reciprocal of a. 5/2. Right? Anybody see how I got that? There's negative b, there's my 1/2, and there's my 1 over a. Right? Okay, so if I simplify all that, what's going to happen? 5's canceling. 2 times 2 is 4. 16 over 4 is what? So we just get 4. H is 4, right? So there's the x coordinate of the vertex. How do I always find the y coordinate that goes with an x coordinate? Plug it in. So we know that k has to just equal f of h, right? Every time. Okay? So you don't have to do the whole vertex form thing. All you need to know is if I get the values of h and k, what's the value of a in my original function? 2/5, right? There's a. A is 2/5. So if I know the vertex and I know a, that allows me to find that a allows me to dilate one of my parent points on my original graph, right? And we're done. Okay, so let's do that. So first of all, what's k going to be? F of h means I'm plugging 4 into my function, so I'm just going to get 2/5 times 4 squared minus 16/5 times 4 plus 37/5. 4 squared is 16, right? 16 times 2 is 32. So I get 32/5 minus 64/5 plus 37/5. Well, 32 and 37 is 69 minus 64 is 5. So I get negative 5/5, which is, or positive 5/5, which is 1, right? So if k is 1 and h is 4, my vertex has the coordinates 4, 1, okay? And I know that, so I'm gonna go over to the point 4, 1 for my vertex. So over 4 and up 1. And a, we already said, is equal to 2/5, right? So I'm just going to multiply all of my normal undilated y-coordinates of a regular x-squared parabola, whose vertex would normally be at the origin, right? So I'd go over 1 and up 1, over 2 and up 4, over 3 and up 9, over 4 and up, over 5 and up. So which of those would be convenient to multiply by 2/5? There you go, so 25. So instead of normally going over 5 and going clear up plus 25, well, if a is 2/5, we're just gonna go up instead. A times 25 equals 2/5 times 25, which is what, 10? Okay. So we're only gonna go up 10, right? So where's that? Starting at 1. we're
Just
gonna
about
go-
where you're going from.
Yeah, just about. We're just gonna go up to there,
That's
right?
11.
Well, I started at 1.
Oh, yeah.
So the coordinates of that point would be what then? I'm going over by 5, so I'm at 9. And then I'm going up 10 from 1, so I'm at 11. Okay, and so the parabola should be, oh, let's see here, okay. All right. Not so great, but you get the idea. Something like that. Okay? We'll just look for the one that has those 2 points. Make sense? Okay? All right, back to it.